Welcome to another math problem of the week. Counting of triangles. Let's talk about it. For today's question, we are asked to find the number of triangles in this figure. As it is not easy to get the exact number of triangles, we suppose that there are n triangles in this figure. A, in between 90 and 95. B, 95 and 100, C, 105, and D, 105 and 110. What do you think?
Pause the video now if you wish to solve it. Keep watching the video once ready.
There are few methods to solve this problem. Yesterday, I present you an easier version, that is the number of triangles for this figure. So for this figure itself, we can count that there are 16 triangles. And you can see that we have actually a 4 copy of this triangle. Our first approach is we just consider 4 disjoint set of this triangle. From each of these, we have 16 triangles. 4 of this, and the number of triangles will be equals to 64. And we look at the triangle made up by this particular figure. Suppose the number of triangles that we can find here is equals to k, then by symmetry, we have extra 3k triangles, because surely they do not have any intersection. Then we are going to count how many triangles that we can have right here. So in order to do this, let's focus on the triangle that we can find on this line. Based on this line and the point here, we can actually have a triangle that we haven't counted from here. That is 1 from here, 1, 2, 3. There are 1, 2, 3, 4 triangles that we can find using this line and this point here. Okay, so with this, there are extra 4 times 2 because of symmetry. So there are 8 triangles based on this line and either this point or this point. And now we should focus on the triangle made up by this line. There are 2 triangles made up by this line and this point here. That is 1 and 2. 1 and 2. By symmetry, there will be 4 of them. So plus 4. And there's another one that make up by the whole line and the center point here. So this is another one. So altogether we have 13. If we carefully count, these are the possible triangles that it is different from the triangle we have considered previously. And this is only one part of this. And by symmetry, we will have 3 times this number of triangles. So let us go back to the original question. So the number of triangles will be equals to 64 plus 3 times 13, and don't forget the biggest triangle, that is 1. So 64 plus 39 plus 1 is 40. So the answer is 104. So we will say that the number of triangles make up by one smallest triangle. And for this, it will be 1, 2, 3, 4, 5, 6 times 4, that is 24 of them. If it's made up by 2 smallest triangles, then it will be 1, 2, 3, then times 4, 3 times 4. But don't forget, there are some overlapping, that is 1, 2, 3, 4, 5, 6. And that is 6. So total will be 12 plus 6, that is 18. Then the number of triangles make up by 3 smallest triangles, then we can have 1, 2, 3. This one here, there's 1, 2, 3, 4, 5, 6. 6 times 4, 6 times 4, that is 24. And if it's 4 smallest triangle, then you can get it from 1, 2, 3, 4. You can get it from here. You can either get it from here, 1, 2, or 1, 2, 3, 4, 1, 2. So there are 4 from each side. So it will be 4 times 3. That is 12. And we look at the number of triangle. If it's made up by 5, it is not possible. If made up by 6, it will be this smallest unit, and you have 4 of them, 4. Or it can be some overlapping between 2, 1, 2, 3, 4, 5, 6, 1 and 2. So it is 2 times 3. So the total will be equal to 10. And you can also check that there's no triangle made up by 7 smallest triangles. Then we'll go to 8. It make up by 8 triangle is come from here. 1, 2, 3, 4, 5, 6, 7, 8. So there's 1, 2, 3. So there is a 3. 9 smallest triangle. It is come from 1, 2, 3, 4, 5, 6, 7, 8, 9. So 1, 2 from each side. So 2 times 3. 2 times 3, that is equal to 6. And it can be also 12 smallest triangle. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 1, 2, 3, 4, 5, 6. So another 6. And don't forget the largest triangle, which is made up by 24 smallest triangle, that's 1. So with this, we can have a total of the sum of all this, and it is 104. For this problem, we also get responses from overseas, like Malaysia and French. So actually, this is a known problem from the Project Euler. That is, this is a stage 1, this is stage 2. Stage 2 is actually make use of 4 units of stage 1. The stage 3 figure is made use of 4 figures of stage 2. For the question in the Project Euler, it asks for what is the number of triangles. Stage 36. If you're interested, please try it. So, and for now, let's look at other people's solution. If you enjoyed this video, please like, comment and subscribe. That's all for today's lesson. I'll see you next Tuesday. Bye bye.